Solving simultaneous linear equations with three unknowns presented by three matrices. Crammer's rule. We're going to use Crammer's rule in this video, or we're going to learn about the use of Crammer's rule to solve for three unknowns simultaneously. The Crammer's rule states that if a11x plus a12y plus a13z is equals to b1, a21x plus a22y plus a23z is equals to b2, a31x plus a32y plus a33z is equals to b3, then x, the solution of x, or the value of x is equals to dx over dy is dy over d, and z is equals to dz over d. So how we arrive at dx, dy, and dz, and even d is as follows. So where d is a11, a21, a12, a22. So d is the matrix forms from this getting coefficients of each of your nodes. You know, when you write this out in this equation in matrix form, that's the matrix D. Then dx is when you replace it, you cover the x column and replace it with the answers, which forms a matrix on its own. You know, we're looking at solving simultaneous linear equations with three unknowns using inverse method. You know, if you had something like e to 2e plus 3 2x plus 3y plus z equals to 2, 3x plus 4y minus 3z equals to minus 8, and x minus 2y plus z equals to minus 1. These are simultaneous equations where we have three unknowns. So what we do, first for writing matrix form, we take it by column rather. We'll take it by column. Is the matrix of the form 2. We take the coefficients to 3, 1, 3, 3, 4, minus 2, 1, minus 3, 1, and then we bring out the unknowns, the variables x, y, z equals to, and the answer we also form a matrix 2 minus 8 minus 1. So you know that this also, that's exactly what, once we form a matrix with the coefficients from simultaneous equations, we're going to have the matrix D matrix, which is this class, and then dx, dx is this column. So to get dx, according to Crammer's rule, to get dx, we replace the x column by the answer, the matrix formed by the answers. So we'll put everything, this rule, in place of x, and then we get the determinants of that matrix that is formed. So you could see that dx rather, instead of a11, a21, a31, you have b1, b2, b3, which means that is the x column has been replaced by the right hand side b column. Then you look for the determinants of this matrix and get the answer of dx. Then dy, the y column will be replaced by the right hand side b column. So all of this column will be replaced by this column. So if you're going to have a11, a21, a31, but in place of a12, a22, a32, you're going to have b1, b2, b3. So that is the y column has been replaced with the right hand side b column. Dz is also the replacement of the z column. Yeah, so instead of, you can see that a11, a21, a31, a12, a22, a32, b1, b2, b3. Replace the z column, which is this column, by this right hand side column, which is this column here, the answer column. Replace it by the right hand side column. Then once you do this, look for the determinants of this matrix, look for the determinant of this matrix, look for the determinant of this matrix, and then to get the solutions to x, y, and z, the values of x, y, and z. X will be dx over d, that's the value of the determinants of this matrix over the value of the determinants of this new matrix. Same goes to y and z. So in a nutshell, if we want to get the x from this column, the x equals to determinants of, we replace this 2, 3, 1 with this answer column 2 minus 8 minus 1, and then we look for the determinant of this matrix dx. To get the y, we replace the y column only. So from our original matrix, we have 2, 3, 1. So we're going to replace the y column with this column on the right hand side of the equation, 2 minus 8 minus 1. Then we'll look for the determinants of this matrix and get the value for the y. Same thing goes to the z. So to get the z, replace, okay, this will give us 3, 4 minus 2. So replace here with the answer 2 minus 8 minus 1. Then look for the determinant of this 3 by 3 matrix. And once we've gotten that, the x will become the x solution to x will be dx over x. Then for y is equals to dy over d, for z is equals to dz over d. That's what the Crammer's rule is all about, and that's how to use it to solve for three unknowns, to solve for three unknowns simultaneously. Okay, so we're going to use Crammer's rule to solve this set of equations simultaneously. So the first thing we're going to do is from Cramer's, the first thing is to write this equation matrix form first. Write the equation, matrix form. Horizontal, vertically, it equals 3, 6 minus 2 minus 4, 3, 1, 8 minus 5, 3, x, y, z, 26, 11. So this is the main matrix formed from the simultaneous equation. The next thing I'm going to do is to get the get the determinants of this matrix. So let's call this the main matrix. So let's say d is equals to d is equals to 3, 6 minus 2 minus 4, 3, 1, and let's say 1, 8 minus 5, 3. So this is the, let's say so look at the determinant. The determinant of d is equals to the determinant of d equals to factor 3 plus 3, first row, first column, 3, 1 minus 5, 3 minus 4, first row, second column, 6 minus 2 minus 5, 3 plus 8, and first row, third column, 6 minus 2, 3, 1, yes, 3, which is 9 minus Minus 5 times 1 is minus 5. Minus x minus is plus 4. 6 times 3 is 18. Minus 6 times minus 5, 10. Plus 8. 6 times 1 is 6. Minus 2 times minus 2 is minus 6. 3. 9. Minus x minus is plus. So 9 plus 5 is 14. Plus 4. 18 minus 10 is 8. Plus 8. Minus x minus is plus 6. Plus 6 is 12. So 3 times 14 is 42. Plus 4 times 8 is 32. Plus 8 times 12 is 96. So 42 plus 32 plus 96. 42. 32. 4, 7, 96. 10. 12 plus 9, 16 plus 1, 17. 170. So these are the determinants of D. Next, derive the determinant of dx. So for dx, dx will be, so we're going to replace the x column by the right hand side column. So this will give us 26, 1, 11, and then minus 4, 3, 1, 8, minus 5, 3, and this is plus 26. First row, first column 3, 1, minus 5, 2, minus 4. First row, second column 1, 11, minus 5, 3, plus 8. First row, third column 1, 11, 2, 1, 26. 3 times 2 is 9, minus 1 times minus 5 is minus 5, plus 4. 1 times 3 is 3. Minus 5 times 11 minus 55, plus 8. 1 times 1 is 1, minus 3 times 11, 32. Minus times minus is plus 9, plus 15 is 9 plus 5 is 14, plus 4. Minus times minus is plus 55, plus 2 is 58. 8 plus 8. 1 times minus 32 is minus 1 minus 32 is minus 32. So minus 32 times 8. 32 is 8 times 2 16. 3 times 8 24. 25 minus 2 5 6. Oh, okay, that's minus 32. So 26 minus 14. 264. 264 is 32 minus 256. So These two are positive, so we add them all together, then we subtract this from the results. Three 40. This is the determinant of dx. We'll go next line. The determinant of dy. Dy equals to, for dy, we're going to replace the y column with the column on the right hand side. 36 minus 2 and 26 1 11 8 8 minus 5 3 plus 3 1 11 minus 5 3 minus 26 6 minus 2 minus 5 2 plus 8 6 minus 2 1 11 3 minus 55 minus 26. This one is 18 minus 5 is minus 2 plus 10 plus 8 66 is times 11 66 minus 1 times minus 2 minus 2 3 minus is plus 3 plus 55 is 58 3 58 minus 26 18 minus 10 is 8 plus 8 66 minus x minus is plus 6 plus 2 is 68 174 minus 208 plus 544. So since these and these are positive, we add them together and then we subtract this from the result and give us 544 510 as our answer. Next, derive the determinant of d z. So determinant d z is equals to, so for d z we're going to replace the z column with the column on the right hand side of the equation. 36 minus 2 minus 4 minus 4 3 1 then 26 1 11 this is plus 3 3 1 1 11 minus 4 6 minus 2 1 11 plus 26 6 minus 2 3 1, 2, 33 minus 1 plus 4. 6 times 11 is 66 minus 1 minus 2 minus 2 plus 26. 6 times 1 is 6 minus 3 minus 2 minus 6. 3, 32 plus 4. Minus times minus is plus 66 plus 2, 68 plus 26. Minus times minus is plus 12. 6 plus 6 is 12. And this will give us 3 times 32. 96. 96. 4 times 68. 272. 26 times 12. 12. Now we're going to add up everything. 680. So now that we've gotten the determinant of D, which is this matrix, the main matrix, and that of dx, we want to obtain by replacing this column by the column on the right hand side, and dy, replacing the y column by the column on the right hand side of the equation, and dz by replacing the column, z column by the column on the right hand side. The next thing is, so you can see, so x is equals to dx over d, y is equals to dy over d, and z is equals to dz over d. So come here, so x equals to dx over d, dx. The determinant of dx is 340. 340 over 170, and this is equals to, and then this is equals to, that's equals to 2. And then y is equals to dy over d, and dy is 510 over 170. Yeah. That's equals to 2, and the z is equals to dz, which is 680 over 170. 680. 680 divided by 170 equals to 4. As it therefore x is equals to 2, y is equals to 2, and z is equals to 4. Let's check if our answers are correct. We'll call it check. So 3x is 2 minus, in place of y we put the value, y is 3 plus 8, z is 4. Let's see if our answer will be 26. So 3 times 2 is 6. 4 times 3 minus 4 times 3 is minus 12, plus 8 times 4, that's 32. That's what 6 6 minus 12. 6 minus 26. Shit. It's equal to what you have here. So 6x, 6 plus 6 times 2 plus 3, 3y, y is 3, minus 5, z. 6 times 2 is 12, 3 times 3 is 9, plus 9, 5 times 4 is 20. 12 plus 9. 1. Also shit. Then next one, minus 2, x is 2, plus y, which is 3, plus 3, z, which is 4. Minus 2 times 2 is equal to minus 4, plus 3, plus 12. So minus 4 plus 3 equals to minus 1. Minus 1 plus 12 is 11. Shit. So our answers are correct. Given that determinant of this matrix is equal to 7, find the value of x that satisfies x plus y minus 2 is equal to 1, x plus z. X plus z equals to minus 1, 2x minus 2y plus z equals to 1. If you have watched the video where we looked at solving simultaneously equations with three unknowns using three-by-three matrix, where I used or taught on the inverse method, this question was also part of the questions that was used as an example. There we used the inverse method to solve for these the values of these unknowns. But now we're going to also use this as an example because we're also going to solve for the same unknowns using the Crammer's rule. Okay, so the first thing we do is we add solution, write out equations in matrix form. So if you go over this one vertically, x is 1, x is 1, and 2, and in this second equation, there's no y, so that means 0. So x is, y is 1, 0, minus 2, and then minus 2, 1, and 1. X, y, 0. So equals 1 minus 1, 1. So that's the matrix formed by the two equations. We are going to look for the determinants of d. You know that Cramer's rule states that Cramer's rule states that solution to x is dx over d, solution to y is equal to dy over d, and solution to z is equal to dz over d. This z, that's the denominator, that is the determinant of this main matrix. We're not going to look for it because it's already given to us here on the question. So I'm going to proceed to derive the determinant of x, y, and z. So we say next, derive the determinant of dx. Determinant of dx is equals to so for dx, we're going to replace the s column of the matrix here by the column on the right hand side of the equation, which have the answers to the simultaneous equations on the right hand side. So not really the answers to the simultaneous equations, but to these simultaneous equations as it's given, because from here we're going to evaluate what the true values of x, y, and z are. So 1, 1, minus 1, 1, 1, 0, minus 2, minus 2, 1, 1. Since since it's 1, then try to write it all. You ignore it because anything here multiplied by 1 is the same thing. So I decided to write the 1. So, okay. First row is column 0, minus 2, 1, 1, minus 1, 1, 1, 1. First row, minus 2, plus times minus 2. First row, first column 0, minus 2. First row, third column, minus 1, 1, 0, minus 2. 0 times 1 is 0, minus 1 times minus 2, minus 2. Minus 1 times 1 is minus 1, minus 1 times 1, 1, plus times minus is minus 2. So minus 1 times minus 2 is 2, minus 0 times 1, 0. Minus times minus is plus 2 times plus 1 is 2. Minus 1 minus 1 is minus 2. Minus 2 times minus 1 is plus 2. 2 minus 0 is 2. 2 times minus 2, minus 4. So 2 plus 2, 4. 4 minus 4 is 0. So next, derive the determinant. Derive the determinant of y. The question only asks for the value of x, so we could stop here and use this formula y plus y. X is going to be x over t to get the value of x, just as what I did when I treated this example under inverse method. So I solved for the two unknowns and then also advised you to follow the condition given in exam. If this is an exam question or a test question, a class question, just follow the instruction. But because I'm solving it and I'm teaching, I need to also give the other values so you will see how the Crammer's method is used to solve for two unknowns simultaneously. So I'm going to solve for y and z also. The y, actually the y is equals to. So for the y, we're going to replace the y column by 1 minus by the column on the right hand side. So 1, 1, 2, 1, 1, 2, 1, minus 1, 1, minus 2, minus 2, 1, 1. Equals to plus 1. First row, first column, minus 1, 1, 1, 1, minus 1, minus first row, second column, 1, 2, 1, 1, plus minus 2. First row, third column, 1, 2, minus 1, 1. Minus 1 times 1 is minus 1. Minus 1 times 1 is 1. Minus 1 times 1 is 1, minus 1 times 2 is 2, plus times minus 2, plus 1 times minus 2 is minus 2, 1 times 1 is 1, minus 1 times 2, minus 2, minus 1 times minus 1 is equals to minus 2, minus 2 times plus 1 is minus 2, 1 minus 2 is minus 1, minus 1 times minus 1 gives plus 1, minus times minus is plus 1, plus 2 is 3, 3 times minus 2 is minus 6, so minus 2 plus 1 is minus 1, minus 1 minus 6 is minus 7. Next, derive, let's derive the determinants. Let's derive determinants of z. So this we're going to replace the z column of this matrix by a column on the right hand side. So 1, 1, 2, 1, 2, 1, 0, minus 2, again 1, minus 1, 1, 2, plus 0, minus 2, minus 1, 1, minus 1, 2, minus 1, 1, plus 1, 2, 0, minus 2. So this plus 0 times 1, 0, minus 1 times minus 2 is 2, minus 1 times 1 is 1, minus 1 times 2, minus 2, plus 1 times minus 2, minus 2, minus 0 times 2, 0, 0 minus is minus 2, minus times plus 1 is minus 2, minus times minus is plus 1, plus 2 is 3, 2 times minus 1, minus 3, minus 2 times, minus 2 minus 0 is minus 2, minus 2 times plus 1 is minus 2, is equals to minus 2, minus 2 is minus 5, minus 5 minus 2 is equals to minus 7. So we've gotten determinants of dx, dy, and dz, and we also know the determinants of d, which is this main matrix. So what we do from Cramer's law, using Cramer's law, we say x equals to x over d, y is equals to dy over d, and z is equals to z over d. So x equals to dx 0 over 7. D is this value here. So given that the determinant of this matrix equals to 7, so the determinant of D, which is this, is 7, as given by the question. So 0 over 7 is equals to 0, and y is equals to dy is minus 7. Minus 7 over 7 is equals to minus 1. Z is equals to minus 7. Minus 7 over 7, which is equals to 1. Therefore, x is equal to 0, y is equals to minus 1, and z is equals to minus 1. So as I explained earlier, the question only says we should look for the value of x, not y and z. So in exam condition or class work, if this is the instruction, follow it strictly, just get the value of x and stop. But because I'm teaching with this example, I just feel I need to also get the other values, so you would see how simultaneous equations are solved using the Crammer rule. So these are the values of x, y, and z. We have to solve using Cramer's rule the following simultaneous linear equations. So first, write out the equations in matrix form. So we're going to have vertically 2, 3, only the coefficients vertically, minus 1, minus 2, 3, 5, minus 1, 2. And then x, y, z equals 27 minus 3, 24. Okay, so D will be this matrix. So when you say next, find the determinant of D. Find the determinant of D. So D is this matrix. This part forms from the coefficients of the unknown. So we let D be in cross with this. So find the determinant of D. We need to have the D determinant equals to 2, 3, 4, minus 1, minus 1, minus 2, 3, 5, minus 1, 5, minus 1, 2, plus 2, minus 2, 3, minus 1, 2, minus 1, 3, 4, minus 1, 2, plus 5, 3, 4, minus 2, 3, 2, minus 2 times 2 is minus 4, minus 1 times 2 is minus 3, minus times minus is plus, 3 times 2 is 6, minus 1 times 4, minus 4, plus 5, 3 times 2 is 9, minus 2 times 4, minus 8, 2, minus times minus will give us minus 2 plus 3, minus 4 plus 3 is minus 1, plus minus times minus is plus 6 plus 4 is 10, plus 5, minus times minus is plus 9, plus 8 is 17, 2 times minus 1 is minus 2, plus 10, plus 5 times 17, 35, 5 plus 3, 85, 85 plus 10, 95, minus 2, 93. So the determinant of D, which is the main matrix formed from the coefficients of the simultaneous equations, is 93. Next, find the determinant of dx. So determinant of dx is replace the x column by the column on the right hand side. 227 minus 3, 24, minus 1, minus 2, 3, 5 minus 1, 2. The factor plus 27 minus 2, 3, minus 1, 2, minus 1, minus 3, 24, minus 1, 2, plus 5, minus 3, 24, minus 2, 3, 27, minus 2 times 2 is minus 4, minus 1 times 3, minus 3, minus times minus plus, minus 3 times 2, minus 6, minus 1 times 24, minus 24, plus 5, minus 2 times 3, minus 9, minus 2 times 24, minus 48, 27, 27, minus times minus is plus, minus 4, plus 3, minus 1, minus times minus plus, minus 6, plus 24, minus 6 plus 24 will give us 18, so 18 times plus 1, right, 18 plus 18, plus, minus 9 plus 48, minus 6 minus plus, minus 9 plus 48 will give us 39, 5 times 39, this will give us minus 27, minus 27 plus 18 plus 5 times 39 is 195, plus that 195 plus 18, 195 plus 18, 195, 18, 5 plus 8, 13, 5 plus 1, 10, plus 1, 11, 1, 2, 13, minus 27, 3 minus 7 cannot, 13 minus 7, 6, this 0 from here, 10, 10 minus 2, 8, 1, 186, 186. So next, place the y column by column on the right hand side, 2 to the 4, 2 to the 4, 27 minus 3, 24, 5 minus 1, 2, minus 1, 2, plus 2, minus 3, 24, minus 1, 2, minus 27, 3, 4, minus 1, 2, plus 5, 5, 3, 4, minus 3, 24, plus 2, minus 3 times 2, minus 6, minus 24, minus 27, 3 times 2, 6, minus 1 times 4, minus 4, plus 5, plus 5, 3 times 24, 3 times 4, 12, 72, minus 3 times 4, minus 12. So we have plus 2, Yeah, it's 2. Minus x minus is plus. Let's see, minus 6 plus 24 is 18. 18 minus 27. This is minus x minus plus 6 plus 4 is 10. 10 plus 5. Plus minus x minus is plus 72 plus 12 will give us 84. 84. 2 times 18 is 36. 37 times 10 is 270 plus 84 times 5. 84 times 5. 20, 40, or 20, 420. So we add this to this and then subtract this from the result. So it equals to 420 plus 36. 6, 5, 4, 456, 456 minus 276, 15 minus 7, 8, and 3 minus 2, 1, 1, 8, 6. Next, find determinant of easy. When we replace for dz, replace the z column by this column. 2 to 4, 2 to 4, minus 1, minus 2, 3, 27, minus 3, 24, plus 2, minus 2, 3, minus 3, 24, minus 1, 3, 4, minus 3, 24, plus 27, 3, 4, minus 2, 3. Minus 2 times 24 minus 48 minus 3 times 3 minus 9. Minus times minus is plus. 3 times 24, 72 minus 3 times 4 minus 12. Minus 12 plus 27. 3 times 2 is 9. Minus 2 times 4 minus 8 is 8. 2 minus times minus is plus. Minus 48 plus 9 is minus 39 plus minus times minus is plus 72 plus 12 gives us 84 plus 27 minus times minus plus 9 plus 8 17 equals to 2 times minus 39 minus 78 plus 84 plus 84 plus 27 times 17 459. So we add these two together, then subtract this from the result of this addition of these two. 465. So Crammer's rule. So x from Crammer's rule. From Crammer's rule, x equals to x over d y equals to dy. And z is equal to d over dx. So dx is 186 divided by 93. Is equals to, so y is equals to dy 186 divided by 93, which is equals to 2, and z is equals to dc as 465 divided by 93. 5. Therefore, x is equals to 2, y is equals to 2, and z is equals to 5. So let's run our check. Check. So 2, x is 2 minus y is 2 plus 5, z is 5. 2 times 2, 4 minus 2. 5 times 5 is 25. 4 minus 2 is 2. 2 plus 25, 27. What do we have here? 27. Check. 3. X is 2 minus 2. Y is 2 minus 5. 3 times 2, 6. 3 times 2, 6. That's 6 minus 2 times 2, 4 minus 5. 6 minus 4 is 6 minus 4 is 2. 2 minus 5 is minus 2. And that's what we have with minus 2. Checked. Next equation 4. X is 2 plus 3, 2 plus 2 plus 2, 5 plus 2, 5. 4 times 2 is plus 3 times 2, 6 plus 10. 8 plus 6 is 14. 14 plus 10 is 24. And what do we have here? 24. So this one is also checked. The answers are correct.